Let's look at a few examples of how we can evaluate an expression. Now, as we begin this, we want just to start to introduce a little bit about an order of operations. When we're solving an expression, there's certain things we must do first so that all of us are always on the same page. And some of us remember the acronym called PEMDAS. And again, we're going to unpack this in a few sections down the road, but basically it tells us that when we see an expression, we probably should do things in the parentheses first. E stands for exponents. That's a term that we'll look at down the road. M and D, multiplication or division. And A and S, addition and subtraction. And so this just helps us remember when we solve something, what should we do first in the expression if there were several things in the expression to do. So let's look at an example. 3 plus 4x, and I want to see what happens when x equals 5. How do we express or how do we evaluate that expression? Well, the first step that we're going to do is we're going to insert our variable into the expression. So it'd be 3 plus 4 times 5 be my first step. Now notice everywhere I saw an x, in this case there's only one variable, that's where I included my 5 at. And the notation between the 4 and the x, it's just 4x, but it's understood as being multiplied to that. So in this particular case then, what do we do next? How do we solve this problem down? Well, we follow our order of operations. It says first to do anything in parentheses, any operations inside. I don't really have any parentheses with operations. I just have a parentheses guarding the 5. There's no exponents. Multiplication or division, I do that first, left to right, whatever happens. So 3, and now I do the multiplication, the 4 times the 5. Look at my expression. What's next? There's no more multiplication or divisions. Then I'm going to do either addition or subtraction. Whatever happens first, left to right. So 3 plus 20 gives me a 23. Now imagine if I did this out of order, and this is something that easily could happen. So let's go back and look at 3 plus 4 times x, and we're going to substitute our value in. 3 plus 4 times our x, which was a 5. Okay, both right here and right here are the exact same equations, same expressions. The multiplication is just worded a little bit differently, but they are exactly the same. So what would we do next? What if we didn't have this order of operation? What if we chose the 3 plus the 4 first? So we would get a 7 times a 5, and then our result would be a 35. We would get two different answers. So how do we know which one's right? Well, we chose as an industry standard to follow that process so that we can get a simultaneous or a consistent solution as we work through these problems. All right, let's look at another example. Say I have 4 plus x plus 3. Well, 4x plus 3. And I want to evaluate it also at x equals 5. So what should we do? Rewrite the expression. Everywhere I see the value x, let's insert what that value would be. So the expression and the expression evaluated at that value have the same look. I just replaced the value of x, which is a variable, for a specific value, in this case, which was 5, and then we solve that. Order of operations is helping us understand we must do any operation within a parentheses. Here, I have an operation within a parentheses. There's an addition, 5 plus a 3. So I would have 4 times whatever 5 plus 3 is, which is an 8. And now I have 4 times 8. And again, this 4 parentheses, the parentheses serve as multiplications as an idea. So these two, 4.8 or 4 times 8. Those are 3 different ways that we want to become comfortable understanding what a multiplication operation can look like within an expression. and then 4 times 8 equals 32.